Alright, today we are going to be talking about simplifying algebraic expressions, and this is going to be our first lesson in the next few lessons that we're going to be solving algebraic expressions. Now today the lesson is fairly simple because we're mostly going to be focusing on combining like terms. We do have some vocabulary words today, 4 of them. The first one's going to be term, which is the parts of an expression that are added or subtracted. A like term should be 2 or more terms that have the same variable raised to the same power. Equivalent expressions have the same value for all the values of the variables. And lastly, simplify, which is to write a fraction or expression in simplest form. Now, let's take a look at this first slide here. It gives us an idea of terms and also like terms. Okay. And then the expression itself, it is color-coded to indicate which terms are like terms and which terms obviously are not. Okay. We have a helpful hint down here. It says constants such as 4.75 and 11 are like terms because none of them have a variable. That means if you just have a regular number with no letter attached to it, those would be considered like terms. Okay. So on this expression we have right here, 7x plus 5 minus 3y plus 2x, if you notice, we do have our 7x and our 2x. Those are color-coded because those are our like terms. Those are actually the only two that we can combine in this expression because none of the others are alike. Okay? So we could actually, this is positive 7x, and since this has a plus in front of my 2x, we could also assume that that's positive 2x. So we have 7x plus 2x would be, that's right, 9x, and then it would be plus 5 minus 3y. And that's as much of a simplification that we can do to this expression because we don't know the value of x and we don't know the value of y. And there's no way for us to solve it because it doesn't say like 7x plus 5 minus 3y plus 2x equals 18. Okay? So there's no way for us to solve this any further than right here. Okay? 9x plus 5 minus 3y. That would be my answer for that one if it asked me for an answer. Okay? All right, let's take a look at our next slide. Combine the like terms. I took the liberty of circling those, or grouping, the terms rather. On letter A here, we have 14a minus 5a. Now, we have to group the like terms on this one. The only kind of terms we have are a. So, we need to look at the 14 and the 5. What is 14 minus 5? 9. And so my answer for that one would be 9a. That's my answer. I can't go any further. Okay? Now, if it told me what the value of a was, well, then we could solve it. Or even if it said like 14a minus 5a equals 128, we could solve for a. But that's not what it's asking us to do. It just wants us to combine the like terms. Okay? Let's take a look at letter B. Letter B is a little bit more difficult because we have two different kinds of terms in this one. We have y's and we have just coefficients, meaning just numbers. Okay? Now, when we're looking at combining these guys, we also need to look at the sign in front of the number because that's going to determine whether or not we're going to add or subtract. Okay? So like this 7y right here, obviously there's nothing in front of it, so we're going to assume that it's positive. This 8, that's a positive 8. This 3y right here, it's actually minus 3y, so when we're combining those terms, we have to subtract 3y. Okay? With this 1 right here, since there's a minus in front of it, we have to subtract that 1 from whatever it is when we're combining those. And finally, we have a y right here that has a plus in front of it. Now, what is that y? Is it 0? No, it's 1. Okay? They don't put a 1 in front of it, but it's kind of like an imaginary one because if it was 0, they wouldn't even put it there. It would just be nothing. But anytime there's just a variable, there's a and assumed 1 in front of it. So let's take a look at this one. Let's combine these terms. So we have 7y minus 3y plus 1y. Yeah, 7 minus 3 obviously is 4, plus 1 is 5, so that's going to be 5y. And then we're going to have 8 minus 1, which gives us 7. So we're going to have my final expression. We're going to have 5y plus 7 would be my answer. Because this 7 right here is positive, if that was a negative 7, then it would be 5y minus 7. Okay? But since it's a positive 7, it's 5y plus 7. Okay? All right, let's take a look at our next slide. This one, we're going to combine our like terms. Again, I've already identified the terms for you. 4m plus 9n minus 2. I identified 3 different terms. Look, m is one term, n's are another term, and then 2 is another term altogether because it doesn't have a variable attached to it. No, it cannot be simplified. That is my answer. The question is the answer on this one because I can't combine anything. So this 4m plus 9n minus 2, that is your answer. Okay? So if you come to one like this on your assignment, don't spend hours trying to figure out what to do. If you don't have any like terms there, then you can't combine them, and then that's your answer. Okay? Questions on that one? No? All right, let's take a look at our next one. This one is interesting. It says simplify 6 parentheses 5 plus n minus 2n. What do my parentheses mean?
Do first.
It means do it first, but they also mean multiply, right? So this means like 6 times whatever the answer to 5 plus n is minus 2n? No, right? It doesn't make any sense because you can't do 5 plus n because those aren't like terms, so you can't combine them. No, the answer is not that. Let me tell you why. Because we can actually use something called the distributive property, which we've done before, okay, way back at the beginning of the year. So chances are you might have forgotten about it. But remember, the distributive property basically says that we can distribute this 6 through this parentheses right here. And basically what we're doing is we're doing 6 times 5 plus 6 times n. Okay? Now, what does that mean? Well, what's 6 times 5? 30. Plus, and then 6 times n is just 6n, minus 2n. Wow, look at that. Now I've got some like terms. Yeah, that's right. Now we can go ahead and combine these n's right here, which 6 minus 2 is 4, so we'll end up with 30 plus 4n. Okay, that's all there is to it. Now, a little refresher again on the distributive property with this parentheses. This works on anything. Okay, I mean, if I were to say, oh, I don't know, 6 parentheses 2 plus 5. Okay, well, what is 2 plus 5? What's 7 times 6? 42, that's right. But if I were to do my distributive property and did 6 times 2, that gives us 12, and then 6 times... That's right. Well, what is 12 plus 30? 42. It's the same thing. Okay? We didn't change anything by doing this distributive property thing down here. It's just usually most of you would rather, well, why would you add, or why would you not add up here and multiply whenever it's, you know, you get the same answer regardless. Okay? But that's what the distributive property does for us. And that's why you learn about it, because it enables us to take the 6 throughout the parentheses, especially whenever we have a variable. That's important because on the second portion of your assignment, you're going to be using the distributive property for sure on number 13, 14, and 15. Okay? All right, let's take a look at our last couple of examples. These are the same things that we were just doing, so follow along. Number one, what are my terms? Or what are my, yeah, just tell me what my terms are. Yeah, all right, my x's, and then 4 is its own term because we don't have anything else, right? So what is my answer to number 1 going to be?
5x.
Yeah, 5x plus 4. Sure. That'll work. Pretty easy. What about number 2? Let's look. 13k and the k. What is this k right here? That's right, it's 1k. What else? Or do I have anything else? Yeah, the 6 and the 9, for sure. And, well, the only one we have left is 8m, so I don't think there's going to be any other thing we can group it with because, well, there's nothing else to group it with. So, since this is a plus, what's my new value for k going to be? Yeah, so we have 14k plus 15 minus 8m, and that's it. That'd be my answer. Now, you could write it in a different order. Like if you're at like 14k minus 8m plus 15, I'd give you credit for it, but this way is perfectly all right. All right, let's take a look at number 3. Number 3, what am I going to do on number 3? What's the first thing I'm going to do? That's right, my distributive property. Remember that? We're going to go ahead and carry that 4 throughout there. So what is my new value for my parentheses going to be? 12x plus 24 minus 7x. Okay, once I have that, what am I going to combine? Yeah, don't forget about our minus on that one. Yeah, so what's 12 minus 7? Yeah, so we're going to get 5x plus 24. And that's my answer. That's not that hard. Okay, what about number 4? Last one. What are we going to do first? That's right. So, yeah, I heard somebody say it. 6x plus 30 plus 3x. Okay, so what are my new values going to be when I combine our like terms?
9x plus 3.
There you go, 9x plus 3. Good. Now, this is our prerequisite lesson. Tomorrow we're actually going to be solving for the equations, but if you don't realize you're supposed to combine your like terms first, it makes it more difficult. So, any questions on that? No? It should be 30, shouldn't it? That 3 right there? I don't know what I was doing.
I don't know. You add them together.
So it should be, sorry, I forgot my 0, which I guess makes a pretty big difference, doesn't it? All right. If there are no questions, then